I welcome all the students. Today we are going to learn the topic which is known as the depth buffer algorithm or depth buffer method. So we have already started learning the topic visible surface detection. Under that we have learned the classification and the backface detection method. Okay, so we have covered up to this. In today's session, we are going to have a look or we are going to learn the depth buffer surface detection method or this depth buffer method in detail. Okay, so let us start our discussion. Okay, I'm just moving to the next slide now. Okay, the name of method, okay, I think we have learned already backface removal method or backface detection. So we are learning the second method that we are having is known as the depth buffer method. Okay, so how this depth buffer method will find out the visible surface, or it is going to find out the, as we are having so many polygons, so many objects are overlapping with each other. Okay, we have to display only the visible surfaces. Okay, so now we are going to find out how this depth buffer method will detect these visible surfaces. Okay, so let us start our discussion. This method is commonly used and comes under the image space approach. Okay, so we have learned there are the two approach. One is object space approach and another is image space approach. Okay, so this method comes under the image space approach to detecting the visible surfaces. Okay, so this method detect the visible surfaces and the name of the method is known as depth buffer method. Okay, the name of method is depth buffer method. Now this method compares surfaces depth. Okay, what you are going to compare, it is going to surfaces depth at each pixel position on the projection plane. Okay, we are going to compare the surface depth at each pixel position, okay, on the projection plane. That was the reason it is known as depth buffer method. Okay, so now this procedure, one very important thing is this procedure is also referred as the Z buffer method or the Z buffer algorithm. Okay, there are so many textbooks refer this depth buffer method as Z buffer method. Okay, so everyone must remember the meaning of Z buffer method and the depth buffer method. Okay, it's same. Okay, so depth buffer is same as Z buffer because Z is considered as the, or it gives us the depth of the object. Okay, so this procedure is referred as Z buffer method since object paths are generally measured from the view plane along the Z axis of viewing system. So we are going to consider that all the objects we are going to view, okay, along the path from the Z axis of the viewing system. So as we are going to concentrate more on the Z value of the object, so it is considered as a Z buffer method. Now, each surface on the scene, or I call it as the each object on the screen or each polygon of a scene is processed separately. So we are going to consider each surface or each polygon separately, one point at a time across the surface. So we can call this method comes under the one point at a time means one pixel at a time. It is going to process one pixel at a time. Okay, so and it will consider each surface of the screen separately, or here each surface means we consider it each object or each polygon. Okay, it should be processed separately. Now the method is usually applied to a scene containing only polygon surfaces. That's why I have said polygon may be of any shape. Okay, so it may have the scene having the polygon surfaces because the depth value can be computed very quickly for the polygon surfaces and the method is easy for the implementation purpose. Okay, so this is what our description of the depth buffer method, or it is also known as the Z buffer method. It will process the image or the scene pixel by pixel, okay, or one point at a time. It also process the each surface or each polygon separately. Okay, and this method, when it is applied to the polygon surfaces, when I'm applying this method to the polygon surfaces, then it is very quickly identify the visible surface and it is easy to implement. Okay, so that's why we are learning the depth buffer method in detail. Okay, let us move to the next point to understand the depth buffer method. Okay, now with object description, okay, we are considering the object description or polygon description, you can say, converted to the projection coordinate. Each x comma y comma z position, okay, each pixel position x comma y comma z on a polygon surface corresponds to orthographic projection point x comma y on the view plane. Actual object is three-dimensional. Okay, it is having x, y, and z value. But when we are going to project it on the projection point, then we are going to consider only the x and y value or two-dimensional view of the object. Okay. Now, therefore, for each pixel position x comma y, every pixel position x comma y on the view plane, the object depth can be compared. So we can compare the depth of that particular object just with the help of by comparing the z value of the point. Okay, so each pixel position x comma y on the plane, okay, object depth value, that is my z value, is compared to find out whether that position, whether that x and y point should be displayed or not, or it should be displayed with which color, okay, on the display or viewing plane, okay, that we are going to decide. Now, following diagram shows the three surfaces. Now, here we are considering initially a first diagram, okay, so that we can come to know that how the depth buffer surface method or depth buffer method will display the object appropriately and how it is going to consider the x value. Okay, so that's why we are considering this example initially. So, following diagram shows or figure shows the three surfaces at varying distances along the orthographic projection, and the line from x comma y in a view plane taken as xv comma yv plane. So because we are displaying the object in x and y plane only, and that is my viewing plane, so I consider this plane is having the value xv comma yv. X is x coordinate, y is y coordinate. We indicate the viewing plane. Now surface S1, now in that diagram we can say which surface is closer. S1 is close at this point position, so its surface intensity value x comma y is saved. Okay, so let us understand the diagram so that we can understand or we come to know that how this depth buffer method is applicable or it is being. Okay, now just look at this particular diagram. See, in this particular diagram, I'm having the three polygon or three surfaces. This is my polygon number one or object number one S1, or I call it as my surface number one. This is my second polygon. I call it as my S2 polygon, or it is my second object and having the surface S2. And this is my third polygon. I call it as it is my S3 value. Okay, so this is my surface number 3 or polygon number 3 or object number 3. Okay, now all these three polygons are there which are overlapping with each other. Okay, they are overlapping each other, and we have to find out only the visible surfaces. Maybe it happens some part of the S1 is displayed, some part of the S2 is displayed, some part of the S3. It depends upon their Z value. Okay, so that we are considering this is our viewing plane. Okay, so I'm just displaying the object in xy. This is my x axis and this is my y axis and this is my z axis, that is depth. Okay, and this is the point I am considering it as xy. So we have considered that the orthographic projection line from the position x comma y. Okay, now from this x comma y I am looking to this all three objects. Okay, I'm looking towards this particular object, okay, in this particular case. And now for all these objects, okay, that I'm looking towards, I considered the z value. Okay, now in this case we come to know that suppose the s value of the S1 surface z value is greater or maximum as compared to S2 and S3. Okay, as compared to these two objects S2 and S3. Now I am talking only about this pixel, this point. For this particular point, suppose S1 value is greater. Okay, then what will happen? It indicates that the S1 object or the polygon is close at this position. S1 is closer, so the color of S1 or x and y value of S1 is displayed over here. Okay, so this x and y in viewing plane belongs now to S1, not to S2 and S3, because S2 and S3 are apart. Okay, they are far away. Okay, and only the S1 will be visible, which is having the Z value which is maximum as compared to S3 and S3 only for this particular point. Okay, suppose I consider, it's okay, I just take another example. Suppose my viewing position point is this. Okay, now this point, this is not intersect to the S1, it intersect to S2 and it may intersect to S3 also. Okay, suppose I consider continue with this line, it may intersect to S3 also, but if for this particular point, S1 will be more closer because the Z value of S2 is will be more closer. S1 is not at all okay having the X and Y value for this. Okay, so it will be a comparison between S2 and S3 and S2 will be closer. So this point, okay, if I'm considering this is my second point, for this point, the point will be displayed with the color of the S2. Okay, because that is visible to that particular point. So in this way, we are going to find out the visible line and the visible surfaces in the depth buffer method. Okay, so the Z value of the polygon or the surface which is closer, which is close to my XY plane, okay, or I say which is higher, maximum between S1, S2 and S3, maximum between all the polygons, and now I am going to display the XY position or the point on my viewing plane with that particular polygon whose Z value is maximum. Okay, so this is what this particular diagram shows. I read the description of the diagram, you already learned this. Okay, let us understand it one more time. At view plane position x comma y, surface S1 has the smallest depth from the view plane. Now if I consider this is my Z value, okay, definitely it is having the, it is going into negative direction. Suppose I consider, so this may have the maximum Z value, this Z value is less than this Z value is less than this. Okay, so it is having more closer depth value from the view plane, so it is visible at this particular position. Okay, and that we have to find out, and that we are going to understand. Okay, so this is what the basic method or basic steps of the depth buffer method that we have shown with the help of this diagram. Okay, further we continue. Now we are going to understand the step-by-step procedure, then we go to the algorithm. Okay, and then we go to the some other example if it is required. Okay, so let us understand, continue our discussion. I'm moving to the next slide now. Okay, so we can implement, now we are talking more about the implementation part of the depth buffer. Okay, we can implement the depth buffer algorithm in normalized coordinate so that the Z value, okay, what is the range of Z value? What is the expected Z value range? The Z value ranges from 0. Okay, 0 means it is the back clipping plane to the Z maximum at the front clipping plane. So my Z value will move from the 0 value to the Z maximum. Okay, so that we are considering Z value 0 to Z value maximum that we are moving. Now the value of the Z maximum. Now Z maximum indicate it is at the front clipping plane. So whose Z value maximum means that pixel is visible. Okay, that surface is visible. Okay, the value of Z maximum can be set either to 1 for the unit cube or the largest value that can be stored in the system. What is the maximum value of Z? Z maximum may be 1 if I am considering unit cube, or it may be the largest value that can be stored in the system. Suppose I am having the system with the Z value maximum 1024, I can set the Z maximum to 1024. Okay, so whatever the resolution we are having, we can set the Z value to the largest value. Okay, next point is, now here if we look at the depth buffer, now this depth buffer requires the two buffer areas. Okay, so I need to maintain two separate buffer, or I think we have already learned the concept of the frame buffer also. So we require the two separate buffers are required, one to store the Z value and another is to store the refresh value or the normal frame buffer. Okay, so normal frame buffer is required, along with I required one more buffer which will I call it as the Z buffer, or which I call it as the depth buffer, which store the polygon which is having the maximum Z value. It is going to store the pixel XY of the polygon or the object whose Z value is maximum. Okay, so that's why it requires the two buffer areas to be required or to be used. Now, which are these two buffer? So first buffer is the Z buffer or the depth buffer is used to store the depth value for each XY position on the surface or process. Okay, so first depth buffer or Z buffer is required to store the value of X and Y position on the surface, which is I am going to process, and I'm always going to store the Z maximum value. Okay, and I required another buffer for the refresh buffer, or it is also called as the frame buffer, which is going to store the intensity value of the each position. Okay, intensity value of the each position. See, suppose for one polygon, okay, having the xy value whose z value is maximum and its intensity is yellow color, okay, and it is having the z maximum value. So xy point will be displayed with the yellow color, okay. Why it is yellow color? Because yellow color is the intensity or color of that particular pixel that should be stored in the refresh buffer. And what is its z value? Its z value should be maximum comparing to all the polygons or the object which are there in the scene. Okay, so that's why we required two separate buffer for this particular purpose. Okay, now let us continue our discussion. I'm just moving to the next slide. Now I have highlighted this point because these points are important. Okay, that's why I'm having some different color. Okay, so I want to find out what is the initial value I have to set. So initially all the position in the depth buffer are set to 0. That is the minimum depth. So initial value of all the pixel or all the position in the depth buffer or the z buffer should be 0. They have set to 0, which is minimum depth. And what is the initial value of the refresh buffer or the frame buffer, which is initialized to background intensity or color. Okay, so and as I'm going to compare, I set the new intensity on it. I'm going to set the intensity of the buffer whose z value is maximum, and that color I'm going to set over there. Okay, so maybe it happens some part is displayed on the background, there is no object, so it will be displayed with the background color. So initially it is better to initialize all the pixel with the background intensity for the depth buffer. Okay, so that is what we are considering. Okay, now if I continue our discussion, each surface listed in the polygon, okay, here you consider each surface listed in the polygon table is in process. Suppose I am having the three surfaces or the three objects as we seen in the previous diagram. I will process this separately. So I will process S1, I process S2, I process S3. Okay, so these are my three objects or the polygon or the surfaces that I am going to process, and I am going to do this one scan line at a time. Okay, so I'm using the scanline coherence, or we are using the scanline one scan at a time, calculating the depth or the z value at each x comma y pixel position. Okay, I'm going to calculate the depth or the z value at each xy position of that particular surface, and I'm going to process the surfaces separately, and I'm processing it one scan line at a time. So that is from left to right. Suppose I consider it as 480 scan lines or 1024 scan line, I have to scan all the 1024 scan lines. Okay, so that we are going to consider. Now the calculated depth, okay, calculated depth is now compared to the value which is previously stored, okay, which is previously stored in the depth buffer at that position. Initially, what is the depth buffer value? It should be 0. Okay, and now I'm processing one polygon whose z value is suppose 10. Initial value is 0. Okay, at that position. So calculated value is 10. Initial value of the depth buffer is z. Now if the calculated depth is greater than the value stored in the depth buffer, yes, in that case what will happen? Initial value I have set to 0, but I have got one surface whose z value is 10. So it is greater than the value which is stored in the depth buffer. Okay, then what we have to do? Then we have to store the new depth value is stored, and the surface intensity at that position is determined. Okay, suppose for that surface the color is suppose or intensity is yellow, then I will store that intensity is considered to be yellow. Okay, for that, and place in the same xy plane location in the refresh buffer. Okay, now I'm talking about this is my first surface I'm comparing. Okay, so now my new value for that particular point is previously it is 0, now it is 10. Getting me? But now suppose while processing the second surface or the second object, I found that that object, okay, which is displayed with the red color, okay, or it is having the red color, whose z value is greater than 10. Suppose its value is suppose 12. Okay, so already stored value is now 10, and now the new value is 12. So what is going to happen? So I'm going to store the z maximum value. So I'm going to store the new value of the z is 12, and the intensity or color is now previously it is yellow. Before that it is background. So now I have instead of background now we set to yellow color, and now it is not yellow, it is red color. So I'm going to set that particular intensity. So it indicates that to the computer graphics that it has to activate this pixel with that particular color, okay, with that particular intensity. Okay, and that is what we are going to do in the depth buffer method. Okay, so I hope all of you understood this, the explanation and the step by step how we are going to do this, how we are going to following it. Okay, but let us consider it with the help of some algorithm. Okay, so we put it in the form of the step number 1, 2, 3, and I call it as we are going to learn it with the help of the algorithm. Okay, so this is my algorithm that I'm having. Okay, so just read that. I think all the description is not so much important for us, but these steps are important. What is my step number one? Initialize the depth buffer and refresh buffer. Okay, initialize depth buffer and refresh buffer so that all buffer position x comma y. Okay, so that all buffer position x comma y, the depth x comma y is equal to 0. Getting me? What is my depth value? In the depth buffer, initial value of all the xy pixel in my depth buffer is 0. Whereas in my refresh buffer, okay, or my refresh buffer or the frame buffer, the xy value is set to background. I indicate intensity. Okay, intensity or the color of that particular pixel is set to the background. Okay, so this is my step number one. What is my step number two now? For each position on each polygon surface, okay, for each position, let me understand each position on each polygon surface, compare depth value to the previously stored value in the depth buffer to determine the visibility. Okay, first what we have to do, we have to calculate, understand this, we have to calculate the depth z for each x comma y position in the polygon. Then we have to check if the z, okay, that we are having, okay, so if my z value is just now whatever I have calculated for my surface or the polygon, if it is greater than depth x comma y, if the z value which is I'm calculated, which I'm processing, is greater than which is stored depth x comma y, then what we have to do, what is my new depth x comma y value, it is equal to z. Okay, otherwise it will not be changed. Okay, so if it is greater, whatever the polygon I'm processing whose z value is greater than depth x comma y means which is already stored. Okay, if it is greater than this, then what I have to do, then my new depth x comma y value which is stored is equal to z, and what is my, in my refresh x comma y, it is already set to background, that pixel is set to background, but now I am going to set the pixel with the surface color, intensity of the surface or the polygon color x comma y. Okay, so just now I have said, for example, my background color, okay, is considered to be the white, and my new color of the surface is suppose yellow, then that yellow intensity will be stored. Okay, getting me? Where I background is the value for the background intensity. Okay, I background is the value for the background intensity, and the I surface x comma y is the projected intensity value for the surface at pixel x comma y. Okay, so I surface x comma y indicate the intensity or the color, for example yellow. Okay, so my polygon is displayed with the yellow color, object is of yellow color, so yellow is my I surface x comma y, and my I background indicate my background color. So my background color is white. Okay, then I background indicate the white color. Okay, after all surfaces have been processed, see, when after all surfaces means all polygons or all objects are processed, the depth buffer contains the depth values for the visible surfaces, and the refresh buffer contains the corresponding intensity values for those surfaces which I want to display it on the screen. Okay, so whatever this second step I'm having, okay, for each position and the polygon surface, I have to follow it for all the surfaces or the polygon. And when this procedure is over, I think in my refresh buffer I'm getting all the pixels which are visible, and I'm also having their intensity or the color value. Getting me? And in the z buffer I'm having the what is the maximum z value, okay, of that particular polygon which is displayed in the z buffer. Okay, so this is what the very easy and small, it is having only 2-3 step procedure is repeated. We have to repeat this procedure, and that is what I say the procedure is easy to implement and easy to understand. Okay, so that's why we are referring the depth buffer method algorithm. Okay, again the new polygon come, compare that polygon z value with the which is stored. Okay, if it is less than it, we don't do anything. If it is greater, again update the depth value with the new value, and again update the, in the refresh buffer, update the intensity of that particular polygon. Okay, and this particular procedure is followed for all the pixel. Okay, and pixel one by one, obviously we are considering all the surfaces or the polygon. For this we are considering, and when I come at the end, I get my visible surfaces value in my refresh buffer or the frame buffer. Okay, so this is what the exact procedure we are having for the depth buffer method. Okay, now while processing this surfaces one by one. Okay, generally we process this from the y value. Okay, first we process from the y value, then we go to the x value. Okay, so let us understand this with the help of the next explanation or the next diagram. Okay, now here what we are considering, the depth value for a surface position x comma y are calculated from the plane equation, okay, for each surface. Now what is my equation through which I am calculating the z value? I think we have mentioned in the algorithm, calculate the z value. But how to calculate this z value? So we can calculate this z value. Z value is equal to minus ax minus by minus d divided by the constant c. Okay, so we are considering already this a, b, c is nothing but a, b, c and this are nothing but a belongs to x, y belongs to b and c belongs to that particular z value. Okay, and so ABC belongs to the viewing position point I'm having, or the, we can say, the viewing normal vector, okay, that we have learned, okay, that is having the ABC value. Okay, so in this way we are calculating the Z value. Now let us understand here. Okay, so I just continue our discussion, then I will come back to the diagram. Let us understand the second line. For any scan line as shown in the diagram. Okay, so now I'm considering this my scan line number y and y minus 1. Okay, for any scan line as shown in the diagram, adjacent horizontal positions. Adjacent horizontal position. These are my adjacent horizontal. See, now I just concentrate on the horizontal position. This is for y line. Okay, don't consider vertical, consider the horizontal position across the scan line differ by 1. Okay, definitely it is having the difference y and y minus 1 differ by 1, and a vertical y value on the adjacent scan line differ by 1 also again. Okay, so I'm considering x to x plus 1 differ by 1, y and y minus 1 which is differed by 1, x axis and y axis. Okay, now what we are going to do, if the depth position x comma y, see this is my depth position x comma y, which is my x comma y pixel, you can find this is my x comma y pixel. This pixel is having the value x and this pixel is having the value y. So x comma y has been determined to z. So I find out what is the z value of this. Then the depth z dash of the next position x plus 1 comma y. So this is my x plus 1 comma y. Next process. This is x plus 1 comma this is y value. Okay, so I am considering this particular pixel. Okay, so x plus 1 comma y along the scan line is obtained. Okay, now to obtain this I am using the following equation. Now here I am having the equation is z dash is equal to bracket minus a x plus 1. Instead of x, now I am processing x plus 1. Remaining things are same, minus by minus d divided by c, or directly I can get here z dash is equal to, because this is nothing but z now. This is I am having the z, so I get it as z dash is equal to z minus a comma c or a by c. So to process this or to calculate this particular value, okay, the formula that we are using. Okay, so let us understand this. Again, I come back to this particular diagram. From position x comma y on the scan line, okay, x comma y means this pixel, okay, on the scan line. The next position across the line is that is x plus 1 comma y. This is my x plus 1 comma y. Okay, and the position immediately below on the next line has coordinate x comma y minus 1. So this is my below position. Okay, this is my next position. My this below position having the value x minus 1 comma, that is x comma y minus 1 is below position, and that we have to process, that we have to consider on the scan line. Okay, now so that's why we can say, okay, the rational, okay, or we can say the ratio, I think we are having the ratio minus a comma c is constant for each surface. So succeeding depth value across the scan line are obtained from the preceding value with a single addition. Okay, so I'm just showing this diagram how we are going to process one by one. Okay, so that is considering the scan line. On my scan line I'm just goes on considering the x and x plus 1 value, and see I'm moving from the top to bottom. Okay, the y value, for y I am moving from top to bottom, so I am considering y, then I consider y minus 1. But for x I am moving from left to right, I am moving in this direction, so I am processing from x, then next value will be x plus 1. Okay, remember my depth buffer value I am processing from the y top to y bottom. Okay, and for x I am moving from left to right side. Okay, that's why we are considering the way we are going to process it. Okay, so let us understand and move to our continual discussion to understand the next point. See, one scan line, we start by calculating the depth on the left edge to the polygon that intersect that scan line as shown below. Okay, so let us consider this line that we are having. See, this is my top scan line. And I want everyone to concentrate on this particular diagram. Let us understand this figure or the diagram. Scan line intersecting a polygon surface. Okay, see, which is my polygon if it is not clearly visible. Okay, if my polygon is not visible clearly, that's why I'm going to outline the polygon. Okay, let us understand this is my polygon. Okay, I think having some pent color. See, this is my polygon. Okay, so in my polygon, I'm having this is my top scan line, and now I'm considering this is my line which is intersecting. So y scan line. Okay, you can find that this y scan line is intersecting the polygon, but how I'm going to process? I'm going to process this polygon from the left edge intersection to the right edge intersection. Okay, that is what I told. Okay, so x value I'm considered the intersection of the polygon from left edge to right edge. So x is processed in this way, left to right. But where if I consider the y value, I move from top to bottom. So the y value is processed in this particular direction. That is from top value to the bottom value. Okay, so we have written here on each scan line, we start by calculating the depth on the left edge of the polygon. So I start calculating from the left edge intersection, then I move up towards the right edge intersection. That scan line as shown below. Depth value at each successive position across the scan line are then calculated. Okay, now here just now whatever I have explained, I have written this point. We first determine y coordinate extent of each polygon. First we determine y value. Okay, start processing from the y value and process the surface from topmost scan line to the bottom. That's why this is my topmost scan line, this is my bottom scan line. Okay, so I'm going to process this y extent or y value from top to bottom, where I'm going to process x value from x left to x right, and that is only for the intersection point. See, if it is not intersecting, mean what will be, suppose I consider this part of my picture, definitely it is stored with the background color, this is also stored with the background color. So it is necessary for this scan line, scan line, to consider only the intersection at the left edge and the intersection at the right edge that we need to consider. Okay, and that is what is shown in this particular diagram. Okay, so I hope all of you are very much clear with the, see, the depth buffer is processing the every polygon or every surface separately. Okay, that is clear. Second, it is going to process this each and every pixel by pixel. And how it is pixel by pixel? It is considered scan line by scan line. Okay, so it will start with the top scan line and then it will reaches to the bottom scan line. Okay, so that is what we are having. Start with the top scan line and reach up to the bottom scan line. Now, while I am considering this y scan line, okay, I'm considering this, suppose the scan line as a y scan line, or suppose you consider it as a horizontal line. Then we have to find out, suppose I'm having any surface or the polygon, then we have to find out the left edge intersection so that I can start my calculation from left edge intersection to the right edge intersection. Only for this, I think I have to find out the, I have to calculate the z value. Okay, and I'm going to compare it with the stored depth value or the z value, and accordingly I'm going to process. Okay, so this is what all is shown in this particular depth buffer method. Okay, now suppose I'm going to consider for the x value, I think I have shown easily for the y, and I'm moving from, for y value I'm moving from the top scan line to the bottom scan line. Let us understand for x how it will be processed or the surface. Okay, so I'm just moving to the next slide to understand this. Okay, starting from the top vertex, okay, we can recursively calculate x position down a left edge of the polygon. So my x dash will be, okay, x minus 1 comma divided by m. So my new value of the x will be x dash is equal to x minus 1 divided by the slope or the m, where m is the slope of the edge as shown in the diagram. Okay, so I'm showing it this particular case here. See here, okay, it is very clear that I'm processing it scan line by scan line, and I'm processing it by with the help of the y scan line, and that is again from top to bottom. Okay, but for x, if I'm having two lines and they are intersecting, so that's why we have shown this particular diagram. Intersection position on successive scan line along a left polygon edge. Okay, from the left polygon edge we are considering. Okay, so for y scan line, this polygon, let us look at this y scan line, the polygon intersect at x with this value. Okay, so this is my y scan line intersect at this age, whereas my y minus 1 scan line intersect at this position, so I consider this my x dash value. Okay, so that is what we are going to consider here in this particular diagram. If we are processing down a vertical edge, okay, we are processing down a vertical edge. Now we have shown that we are processing in the down vertical edge. The slope is infinite and the recursive calculation reduces to what is my depth value now? My depth value will be reduced and directly I can calculate z dash value is equal to z plus b divided by c. Okay, because a represent x, b represent y and c represent to the z. Okay, so I can directly calculate the z value by considering z dash is equal to z plus, okay, b divided by c. Okay, so this is my z. New calculated value will be z plus b divided by c, and then I'm going to process this particular equation with this. Okay, I think we have learned so many details about the depth, how it is going to process it, okay, and all the things. So basic, we are having two steps. Okay, everyone remember, we are having basically only two steps here, okay, for the understanding. What is my step number one? First, we should understand we have to use two separate buffers. One is depth buffer, another is refresh buffer. What is the initial value of the depth buffer? It is 0. What is the initial value of the refresh buffer? It should be set to background. Okay, then now I have to process every polygon surface. I have to process separately, and again I am going to process it scan line by scan line. Okay, so whenever I am considering the scan line, suppose I found that this is my intersection point over here at this 8. I am starting from the top. Okay, suppose consider this is my y scan line. So for this particular pixel or the point I'm considering, I'm comparing the calculated z value of this pixel with the stored z value in the depth buffer. Okay, if this pixel is having the greater value, what it indicate? I have to store this new value to the buffer, and in my refresh cycle, okay, I mentioned that this particular pixel should be displayed with the polygon color. What is the polygon color? For example, here it is blue. Okay, so the intensity of this particular pixel should be displayed with the blue, and because its z value is higher. Okay, and this procedure we have to repeat for all the surfaces or the polygon, and we have to process it scan line by scan line. Okay, and that is what we have to consider when we complete this procedure. Definitely my refresh buffer is having all the pixels which are visible, okay, which are closest to the view plane. Okay, and that is what our output. Okay, so this is what the procedure we are having. Now before moving to the understanding which are the advantages and disadvantages of this method, the head buffer or depth buffer method, I think I just want to show one more diagram so that how the output will be displayed. And I may have a number of polygons objects are there. Some polygons may be penetrating, some triangles are penetrating. Okay, so let us understand our next diagram. Okay, so that you will have the visualization of what is my output to be displayed, what is my input to be given. Okay, now let us understand this particular example or the diagram. Okay, in my diagram, just you come to know that this is my diagram number A. You can find in my diagram number A, I am having this x-axis, this is my y-axis, and this is my z-axis. Definitely, the user is viewing from which position? Obviously, I am using, or the viewer is using or looking toward this direction. So this is my viewing system. Okay, so when the user is viewing, if you can look at this polygon, I'm having, this is my polygon. Actually, I'm having only two polygons here, two surfaces. This is my surface number 1, and this is my polygon number or surface number 2. Okay, but here in this diagram, this triangle that I'm having, this is my surface number 2 or the polygon number 2, it is penetrating, it has inserted or it is having penetrated inside my first polygon, that is square. Okay, so obviously what will happen, actually this polygon number 1 is at the starting position, or it is front side, and this triangle is back side. But some part of this triangle, I'm considering this is the area of triangle which is penetrated and it has come to the front side. Getting me? It has come to the front side, and some part is there at the back side. Okay, so now this particular position, if I apply the depth buffer method, my output is now shown into the diagram number B. My expected output of the depth buffer is now shown in the diagram number B. You can find that. Okay, see, suppose I am consider this particular triangle is having the brown color. Okay, what is the color of this? Is suppose brown. Okay, so in my display, I can find that this is the visible part and this is displayed with the given color, and this is also the part of my triangle which is visible. So here it is only up to this, but this part is also visible to me, so this will be visible with the given color. My background is white color, getting me? My background color is white color, and suppose this particular square object I'm having, it is having suppose green color, then in my display I can find this particular area, okay, having the intensity or the color which I'm considering it as the green color. So at the my object, okay, actual object will be displayed here, okay, something like this. Okay, so this is the surface which is visible, this is the surface also visible, this is surface which is visible, okay, in my two-dimensional view, and that is done with the help of my depth buffer method or my depth buffer algorithm. Okay, I think this diagram has helped you to understand. Suppose I'm having one more object, or suppose it is a square. I'm just showing you. Suppose I'm having one more object as a circle is there. Okay, and this circle is having some yellow color. Getting me? Then what will happen? Now this particular part of the circle as overlapping on the square, definitely the z value will be higher. Okay, it is front side. So obviously in my two-dimensional, what I will find, I am having this is there, and maybe this is upper side part, so this is no intersection. I may get this is visible to me, and now this particular part is not with the green color, but it is the color of my circle which is displayed. Okay, and in this way I'm going to display my object, and this is what we call it as the method that we are using depth buffer to display the visible surface or the visible line. Okay, so with all this background, okay, let us understand the last slide where we are going to discuss which are the advantages and disadvantages of the depth buffer method. Okay, let us understand only one last slide. We understand what is advantage and disadvantages. Okay, so first point is what is advantage. Okay, I just want to highlight what is the advantage of the depth buffer method. Yes, this is my first advantage. Okay, what is my first advantage of the depth buffer method is, okay, it is very easy to implement. Okay, implementation is very easy. Maintain two buffers, just compare the z value and then appropriately update the refresh buffer. Okay, it is very easy to implement. Okay, this is my first point. What is my second point? See, my second advantage is it requires no sorting of the surfaces in the scene. Suppose I'm having 5 surfaces, 5 polygons, 5 objects, okay, in my scene. There is no need for me to sort it. I can start from any surface. Okay, take the surface number 1, then 2, 3, 4, and 5. There is no need to any type of the sorting is not required. Okay, so no sorting is required. So in that case, I say the time which is required, okay, for the sorting will be reduced. Okay, so it is easy to implement as well as it may take less time because there is no process of sorting surfaces. Okay, but what is the drawback? Is there any drawback of this depth buffer algorithm? Yes, and that drawback is it will require more storage space. Okay, the disadvantage is it requires more memory. Okay, more memory space is required. Okay, so this is what I have mentioned here. What is the disadvantage of this particular method is, okay, it requires the availability of the second buffer in addition to refresh buffer. It requires refresh buffer as it's already there, but it requires one more buffer, which is we call it as the depth buffer or the z buffer, and due to that the memory requirement is more. Okay, it will require more memory, that is the drawback. A system with resolution of 1024 by 1024, suppose I'm having the image of 1024 by 1024, would require over a million positions in the depth buffer. Okay, so definitely the depth buffer should be required, whose size is again 1024 by 1024, okay, which is required additional to my refresh buffer or the frame buffer. And this is the main disadvantage, the memory requirement is higher. Okay, because with each position containing enough bits to represent the number of depth increment needed. Okay, so simply I can say storage or memory requirement of the depth buffer or z buffer algorithm is higher, and this is what my I say this is the disadvantage of my z buffer algorithm. Okay, now still there is some improvement is possible to remove this disadvantage, and I have just mentioned this. One way to reduce the storage requirement is to process one section of the scene at a time. Okay, process only one section of the scene at a time using the smaller depth buffer. Instead of using 1024 by 1024 buffer, use small part of the buffer, okay, as a part of the buffer, and use the same buffer for the next part. Okay, after each section is processed, okay, so in that case you have to divide the image into the different scenes or different subparts. Suppose I divide my image into the 4 subparts. Okay, so my requirement will be 1/4 will be reduced. Okay, smaller depth buffer. After each view section is processed, the buffer can be reused for the next section. Okay, and that is the solution that we are having. But still, I required the separate buffer to be maintained, and that is the drawback. And definitely I can reduce my storage requirement, but additional memory space or the storage is required, okay, in my depth buffer method. And I say this is the drawback of my depth buffer algorithm. Okay, so if the application is not having any restriction or it does not require any constraint of the memory, okay, or the storage requirement, then it is better that we should go for the depth buffer method should be used for the visible surface line display or visible surface detection and displaying it, because it is having the advantage, it is easy for us to implement, as well as it is not required to sort the surfaces or the polygon. I can start from any polygon. Okay, not necessarily I should start with this polygon first, then second, then this is the next one. It is not necessary. I can start with any surfaces or the polygon. Okay, and this is what the main advantage, okay, I'm having with the depth buffer. The only drawback is the more storage requirement or the more memory is required or additional memory is required. Okay, along with refresh buffer, we have to maintain the depth buffer also, and this is the drawback of my depth buffer algorithm. Okay, I think we have seen all the details of the Z buffer algorithm, starting from the, okay, what is the basic thing, then in the algorithm in detail, how it is processed with the Y scan line, how I can process with the X value also, how to compare which formula to use, okay, as well as the diagram and its explanation and the example. Okay, so I think this is all about the understanding of the point depth buffer, or it is also known as Z buffer. So many books refer it as a Z buffer. I'm repeatedly using this word depth buffer or the Z buffer method, which is used for the visible surface detection. Okay, so I think we should end our session here. I hope all of you have enjoyed the learning the depth buffer algorithm. Okay, so thank you all the students.